Hey guys, welcome back. Mr. Will here. This is a video lesson for Feed Me Pie and Divide and Conquer for April. What is today? The 21st. Wow. 2020 for the groups Feed Me Pie and Divide and Conquer. Yesterday and the end of last week, we were solving problems that had to do with percent of change. Today is a very similar topic, but it's a little bit different as we explore percent error. So what that means is there was an original amount, and there's actually the actual amount is a little bit different. Okay, there's an error. So it describes percent error describes how far off a value from the actual answer may be. This might make a little bit more sense as we look at this problem. So there's a lot of similarities between this problem and what we just were solving and working with percent change. So let's check it out. Leo estimates that a package weighs 24 pounds. So he's like, picking it up like, yeah, I think this weighs 24 pounds. He takes it to the post office and the postal clerk weighs it and says, I don't know, Leo, this package, according to my scale, weighs 20 pounds. So the question is, what is the percent error in Leo's estimate? He thought it was 24, but it turns out that it was really 20. Well, there is a formula to solve this. Just like we were doing percent change, there's a formula to solve this type of problem. So if we look at it, it looks really similar. The amount of error goes in the numerator. The actual amount goes in our denominator, and that equals the percent of the error. So x over 100, because percents are a number out of 100. So if I look at this, I'm trying to find the amount of error. So what I do is I take my value 24, and just like percent of change, I'm going to subtract it from 20. So I have 24 minus 20, and I'm going to divide that by the actual amount, and the actual amount is 20, what it really weighs. So I'm going to divide that by 20, and that's going to equal x over 100, because we're trying to find the percent of the error, okay? So now we have filled in our information into our formula, and we're going to solve it. So 24 minus 20 would give me 4. 4 over 20 equals x over 100. Now, again, I can solve this in one of two ways. I want you to think about what is the way that would make the most sense for you. The first way, or these are now fractions. These are proportions, but it's very similar to fractions when you have equivalent fractions. How does this 20 become 100? Well, 20, 40, 60, 80, 100. I'm multiplying by 5. So if I multiply this 4 by 5, the same thing to my numerator, 5 times 4 would give me 20. So x equals 20. There's a 20% error. Okay, so he thought it was 24. It ends up being 20. There's a 20% error in this problem. Now, another way to solve this is to cross multiply. So if I cross multiply here, okay, same structure, okay, 4 over 20 equals x over 100. I'm going to cross multiply here, okay? And when I do that, I do 4 times 100 and 20 times x. So that would be 400 equals 20 divided by x. And isn't this really interesting? I do my inverse operation to isolate the variable. So if I'm multiplying, I'm actually going to divide, because 20 divided by 20 gives me 1, or just x. And then 400 divided by 20 gives me, wait for it, it gives me 20. Okay, so x equals 20. Okay, 20% is the rate of, percent of error. Now today, I want you to work on using this formula to find percent error. Work hard, keep asking questions. I'm here to help you guys. Good luck, and I'll see you on